Hello, my name is Pericles. I'm an adjunct faculty at the Hellenic Naval Academy, and I will be briefly present you a pilot project that we do, the development of a control vocabulary. I would like to thank WSCAS for inviting me for this guest presentation, and I'll move forward. I just want to say just before I move on with my presentation that this is a pilot project, and I'm going to be talking about the second phase of the project, as the first phase has already been done and published in IEEE for the DSERT conferences. So this is the outline of my presentation. I begin with some information on what is, let's say, control vocabulary and what is terms, and I give you the background context of my presentation. Then I move on with a couple of related research about, how to develop a control vocabulary, and I present my methodology, and I provide maybe a toy example, and then I refer to the preliminary or pilot results, if you like, and I conclude the presentation with the next step of this research. So, in introduction, I'll say that a control vocabulary is a collection of terms that are being used in a domain. So, for instance, they describe what is being talked about in a field. For instance, we have the field of engineering or the field of physics. So you use specific terms or concept, if you like. So, so a control vocabulary is a collection of terms. And we can use a control vocabulary to, as this point says here, to mitigate data ambiguity. For instance, we have a database with proper names, and in order to make sure the differences between the names that we wanted to retrieve from a database, we can use a control vocabulary so we can so we know for whom we talk about. Because if we have names such as Robert Smith and Ronald Smith, when both have the first name John, and then they have abbreviated terms of their names or acronyms, that makes it difficult to retrieve. So if we have a control vocabulary, we have a foundation, or we have like the structure on how to retrieve the information that we need. Then we use control vocabulary to define the characteristics of knowledge resources in a specific domain. For instance, we can have a control vocabulary to help us define a URL or a URI, if you like, to retrieve information from the web or web sources. And we can use a control vocabulary to assist with semantic interoperability. This is for automated data exchange, as the point on the slide says. For instance, we have different computer systems. We have, let's say, two different hospital structures that they use different computer systems, like different medical records, for instance. Or we have like different organizations that use different software applications to retrieve data or to manipulate data or exchange data and stuff like that. So if we have, they probably use different terms or different terminology, but they refer to the same thing. So we can have a control vocabulary that sort of aligns the different use of terms or the different use of application between different organizations. And we can use control vocabularies to facilitate integration of ontologies. Ontologies are concepts and relations between concepts using a domain. So a control vocabulary can help to integrate existing ontologies to build a single coherent one based on shared concepts between different organizations or different individuals and stuff like that. For instance, we have the term wall of lyosome and lysosomal membrane, which are basically the same thing. So we have a control vocabulary. We can tie this to these terms that mean the same thing, but are expressed differently. So term is a designation of a concept in a specific subject field, and it can consist of one or two words. For instance, a term can be, for instance, I don't know, airplane, plane. An airplane is also a term. So we have two words for one term. So a concept or a notion is a different word for a concept, right? Is a mental representation of something that can be considered a unit of knowledge. So that's about the introduction of what is a term, what is a concept, and what is a control vocabulary. In different domains, as I said earlier, we have different terms. So in the domain of defense, we can have terms such as the C4I, SR, that refers to command control communications, computers, intelligence, surveillance, and reconnaissance. We have the APC term, which is an abbreviation for armored personnel carriers. And we have other terms like that they come from biomedicine, like biological and bio-inspired structures for multispectral surveillance. So we have a field that is the domain, that's the field of defense that uses different terms, different concepts to define its functions or to define its context that does operations and stuff like that. So all these can be captured and provided in some structured way. So a vocabulary can have the structure of a simple list, like the one that you see here on the left of the screen. It's like a list of terms that are hierarchically or in some way defined and projected in some structure, or it can have a tree-like structure that you see here on the right. The World Wide Web Consortium considers control vocabularies as the basic element of the semantic web. The World Wide Web Consortium is an organization that provides recommendations for the semantic web, which is like sets of tools and applications for tying together linking together disparate data sources on the web. W3C recommends the Simple Knowledge Organization Schema, the SKOS schema, to standardize the creation of control vocabulary in a machine-readable format. Basically, we have terms that we would like to create a control vocabulary, and then we can use the SKOS schema to formalize this collection of terms so that we can use it to computers and make the computer applications work based on this structure. So SKOS is based on machine-readable resource description framework. So this is RDF, and RDF is basically the subject relation object or subject predicate object triple, if you like. These are statements these are triple statements that when they are tied together, they induce a graph. So they provide structure to unstructured information that we can use that structure to do computational analysis of our data. RDF statements are the building blocks of an ontology. As I said earlier, ontology is concepts using a domain and relations between these concepts. And SKOS vocabularies, since are predicated on this RDF schema, they can be defined as an ontology. So moving on. So I provide some brief couple of resources, a couple of bibliography, different scientific domains, scientific fields that use control vocabularies for the purposes. And Giannaris et al. They present the integrating genomic knowledge sources through an anatomy of an ontology. Here they say that the gene ontology is basically a control vocabulary with three hierarchies of terms, with three different hierarchical levels for gene functions, large-scale biological processes, and cellular components. And they use this control vocabulary of three levels to discover information about gene products, to make inferences about gene functions and stuff like that. So basically, Go is a very well-established control vocabulary that helps, scientists in biomedicine, bioinformatics, and health informatics and fields like that. And Solomon et al., they use a control vocabulary for semantic educational resources using SKOS. and learning object ontologies, as it is the project. So here they propose an SKOS model, thematic thesaurus, to make disparate knowledge sources such as libraries, universities, research labs, and stuff like that, to share information and link their disparate data sources. So they provide a structure based on SKOS for knowledge intensive institutions. And I also provide a link, a reference to our earlier work, just to tie our previous research with this information, or with this presentation, or with this research that I'm discussing. Now I'm going into our methodology. So this is this is structure of a methodology, if you like. We begin with a data acquisition. So we retrieve data from a source, and I'll be discussing this later on. Basically, our source is, and since we're trying to define the terms that are used in the Russia-Ukraine conflict, we try to collect information and terms that they come from this conflict, and we try to find these terms in NATO press releases, which are rich sources of information about defense and civil and diplomatic events and stuff like that, political events. And so we take this information, we extract a sample of press releases, we do some data wrangling. That means that we try to do some, we use algorithms to process or pre-process, if you like, our data. And then we take this information and we do some classification, as we say here, and then we do some more, we extract terms, and we do the, and we try to apply to the SKOS schema. And as I'll be discussing, until we have the first version of our control vocabulary, which is then assessed by an algorithm, as I will be discussing. So for data acquisition, we use a NATO press office, the news site. We have a search query, which is based on the keywords are Ukraine, Russia, and conflict. And for this second phase of our pilot project, we collect data between these dates, and then we do some data analysis in order to remove some artifacts that we're not interested in analyzing in this phase of our project. So we remove some artifacts and some other data, or let's say metadata, related to the data that we collected. We organize our data into a spreadsheet, and then we do some word analysis that basically has to do with frequencies and a number of unique words. Basically, we do some counts and some frequencies and stuff like that. And then we move on with annotating our data. So for that, in order to annotate our data, we use a code book, right, that we have developed in the first phase of our pilot research, and we take these and we use some applications, the Label Studio, which is provided by DAXCAB, for instance. We use that, and we collect our labels from our early project, from our code book, and we start applying it on our text. So, for instance, wherever we find terms such as Secretary General, proper names, city names, and stuff like that, we tag them in a named entity recognition approach. And named entity recognition is a computational technique that tries to identify named entities in a text. So we take this approach, and then what we do, we take the output of that process, and then we use some computer scripts. We use R and Python, for instance, and we separate the rest of the data. So we keep the terms under labels that we have, and then we move into the next step to basically utilize the SKOS schema in order to on our data, right? Or we try to fit our data on the SKOS schema. The basic SKOS concept that we use are the concept scheme and the concept. These are very basic concepts, okay? And then we also use SKOS relations. We try to make relations between these concepts that we utilize. So we use this number of SKOS relations that helps us to provide a hierarchy to our control vocabulary, right? And some association between the terms. And the result is basically that our search query returns 28 press releases between July the 27th and December the 14th of 2023 as for the second phase. Okay, so basically we extend our early project by these many press releases collected between these dates, as is being stated here. And I'm just providing a very brief information for the most frequent words, as in unigrams. When we say unigrams, we just mean one word that we find as a term in our press releases, in our sample of press releases. So we have, so for instance, NATO appears 23 times in the number in our collective sample of press releases. The term secretary appears 14 times, Ukraine another 14 times, and stuff like that. And then we identify 170 unique terms that we have annotated with our project, and we use 20 different tags for these 170 unique terms. So we extend our earlier or the first version of our control vocabulary by 170 terms, and these are a sample of annotation tabs as an excerpt of annotation for SKOS vocabulary, and these are terms and annotation tags, how they're used. Continuing with results, the SKOS data structure has a 5-level hierarchy. The SKOS prefer label and is for our vocabulary. The preferred label, excuse me, for our vocabulary is Russo-Ukrainian defense diplomacy vocabulary. We use tools such as the COVID control vocabulary editor by the narrow live of the Athens Institution Research Lab of the University of Athens to develop our control vocabulary. So we use this application and the SKOS play to identify, top terms, main concepts, narrow terms, and stuff like that. So we have on the different levels, we use a different number of concepts. We identify a different number of concepts, as this information says here on our slide. And basically, the 5th level, which is the most narrow level of concepts, and is terms that we extract from our text, has 73 identified concepts as such. And this is a tree-like structure of our concept hierarchy. So we have the top, so we have the schema of our concept, and this is a very top concept. And under the NATO concept is all these other concepts, as this example shows. We also, besides using SKOS schema for formalizing the terms that we extract from our press releases, a sample of press releases, we also use the FOAF or FOAF, is a friend of a friend schema. This is a sort of language that helps you formalize relation between people on the web. So we utilize this language as well to sort of encode social relation between between people that we identify as such in our data, and the COVID application that we use for encoding data as SKOS model provides also another functionality, another graph functionality that helps us to isolate, so to speak, or to concentrate on relations between concepts and project them as a social network. So this is another snippet of that work that we did that provides relations between people in the context of the professional context and the relations within the organization that is NATO. For the control vocabulary assessment, we use the SKOA play testing tool, which is a front end for the QSKOS application or algorithm, if you like. We use by default 24 rules, and we have this assessment. Basically, we have 3 warnings. 2 are just simple warnings that have to do with how we have encoded some terms, and basically there are not some link between some concepts or something like that. And there is one failed rule, and that is because we have some associative relations between sibling terms that shouldn't be happening at some level of our concept hierarchy, and that we're planning to address in the next stage of this research. And in discussion, the preliminary text analysis of NATO press releases samples provides an overview of the volume of information pertaining to civil and military affairs, as are found in press releases. Text analysis is the groundwork to capturing and structuring knowledge to be leveraged by computational models, plus it quantifies the text that we have. So it gives us an early view of the distribution of terms and how they're used in press release and the data that we are interested to analyzing and studying. SKOS models data in concept schemes, or SKOS data structure has 5-level hierarchy of concept specificity. This creates a polyhierarchy of concepts. Polyhierarchical approach classifies terms in press releases, also denotes that concepts can potentially belong to more than one category, and probably these can be useful during at some later phase of classification of data for our analysis. The goal of polyhierarchy is to address potential complicatedness regarding a broader, narrow concept relations, and our pilot research to create control vocabulary to formalize knowledge of war, diplomatic, civil events related to the Russia-Ukraine conflict. Utilization of this SKOS concept schema has been very helpful for our project, and it helps us, to formalize checks and work it with our computers. Limitations again have to do with the size of the data sample that we're planning to extend. We're going to try to address again the polyhierarchy of categories, and to then again check the rules that gave us the warnings. And in conclusion, I have been briefly presenting the second phase of a pilot project that has to do with formalizing concepts that we identify in NATO press release about the RU conflict. Utilization of the COVID and the SKOS plate testing tools helps us, develop this project. And then the next step of analysis of full text press releases is our goal, and we take it from there. We'll try to expand our project with the goal to provide a control vocabulary that can help to retrieve information about diplomatic events, civil events, war events, always within the context of conflicts, or armed conflicts. Thanks.